Okay, so when we evaluate the modeling approaches, again, ambiguity, as I mentioned, cannot be removed completely. So you have to be careful. How does the approach help you avoid or reduce the ambiguity? And then accuracy, as you mentioned, accuracy means how correct are our models. So, and the initial models tend to get changed a lot, but we have to be correct as much as possible. So, as an experienced architect might be able to draw very accurate models that do not need to any to correct any errors later on. So how does the approach help you assess the correctness? So there must be some way for us to assess, to verify the models are correct. So one thing we can do is like we can verify whether all the requirements have been actually mapped to a user, right? So all the requirements, whether functional or non-functional, should be raised by some stakeholders. So you can, like, if you carefully verify each of the requirements, then the accuracy can be increased. Then it comes to the precision. So precision is a bit different from accuracy. Precision is how reproducible, or can you do it again and again. Like sometimes when you have inaccurate requirements, sometimes you end up solving a wrong problem, but you might do it very nicely. So precision is how descriptive are you, up to how much precise you are about your configurations, your components, your connectors. So if you mentioned all the middleware software, how each of them are connected, how the user interface should be modeled. So if all the details are there, it becomes precise. So again, you have to decide at what level of detail do you need each of these aspects to be at. So whether you want to specify your hardware, so are you going to use Linux or Windows? Do you want to specify? Then your middleware software, do you need to specify the names, right? So if you want the details, then that is being more precise, right? So at what level of detail can various aspects of the architecture be modeled? So you have to decide at what level you want to keep it, right? So it's like there are industry standards. So if the industry standard is to specify the things, say for banking software, usually you specify all the server types and all the details, then it becomes easier for the implementer and the later designer as well. But in some generic software, then users might like the other the business side stakeholders might ask for different user UX aspects, and these concerns might might affect our decisions about the details, right? So if you get the idea, right? So because if a user requires some particular Excel to be embedded, right, then we will have to use a .NET architecture here. So then that kind of thing might get priority. So then we might not have the high precision, right? So the architectural diagrams will have low precision. So in order to incorporate the later design decisions. Then the viewpoints. So we have to decide which viewpoints are supported by the approach that we are following. So if you are following, say UML. So if you are going to use the UML will only support a certain set of viewpoints. But if you are having a free natural language, say just plain English, okay, just documents. So any viewpoint can be supported by natural language, just writing. But UML diagrams have set up theories that must be adhered to. Then the viewpoint consistency. So as we mentioned previously, sometimes the viewpoints are different viewpoints will give different views. So inconsistent views will result. So we have to be careful that the viewpoints have inconsistencies as well. So how does the approach help you assess or maintain consistency among different viewpoints? Then let's look at some of the modeling approaches. So these are the approaches we have to be aware of, and in the next few weeks, I will go through a few of these notations, right? So there are the generic approaches of natural language. So natural language is just English, right? So just plain English, or it's a bit like the pseudocode, right? So it's a bit like pseudocode. There are like syntax that you have to follow, right? But still it's mainly just English. So anyone will understand it. Okay, there is no hard and fast rules actually. The different companies will follow their own rules in how to use natural language in the in modeling. Then there is PowerPoint style modeling. So you know, in PowerPoint there are a few diagrams that you can draw easily, right? So that is so known as the PowerPoint style modeling. So you just get a Microsoft PowerPoint and draw the images using the shapes available in the Microsoft PowerPoint. Then UML, you already know the Unified Modeling Language. So you can use the appropriate diagrams in UML. So you will not need all the diagrams. So you don't need to use all the diagrams that you have learned, right? But few diagrams that are specifying the important decisions can be used in our architectural modeling. And then there are special languages which are like programming languages, okay, which have been used for architecture description, which are known as ADL, architecture description languages. Okay, a few are Darwin, Rapid, Write, and then there are domain specific languages and style specific languages such as Koala, Weaves, AADL. So we will not go through all these. This is just for your knowledge. Right? Then there are extensible architecture description languages. Now we will look at a few examples of these extensible architecture description languages. Because these days, when you are doing web-centric architectures, is XML, supporting XML becomes sometimes important. So these extensible architecture description languages allow you to extend the architecture into a programming language. So ACME, ADML, XADL, so especially XADL can support the XML or HTML type of code. So you can embed the XADLs in the XML code as well. So that kind of like, that's why we call them extensible architecture description languages. So we can extend the architectural model to your design and later implement on the same document. So which can be useful to reduce errors and to make sure that your implemented design is consistent with the architecture. So we will first focus on the generic approaches of the natural language, PowerPoint style, and the UML for today, right? So let's first look at the natural language. So natural language here is English, and the advantages are it is highly expressive, because you can write anything you like, right? Any word in English language you can use to describe your architecture. So it can be very rich because it just depends on the amount of words you know, right? So anything you know you can write. Then accessible to all stakeholders. So all stakeholders, whether they are from the technical side or from the business side, will be able to understand. So even a business owner will be able to understand this English, because it is only English and it is not following any rules like UML or anything, right? Then it is good for capturing non-rigorous or informal architectural elements like the rationale and non-functional requirements. So since it is having English, so it can include any English word. So all the adjectives, the adverbs that you want to write about, to express about the non-functional requirements, to explain the non-functional requirements, you can now include. So it's a bit informal because the set of word is not limited. So it is not following a given syntax. So we call it non-rigorous. So when you want to make things rigorous, we introduce syntax. But here it is just natural language. So there is no syntax. There is no limitation to there is no set of commands that you use, right? Any word in English you can use. So because of that, it is non-rigorous. And there are a lot of tools available, right? So the tools mean any word processor or any text editor. So it can be Microsoft Word, it can be Notepad, WordPad, it can be any open source software editor, text editor, right? So any tool that can type words can be used as the tool for natural language. Then there are some disadvantages as well. So one thing is ambiguous. So because you are writing in normal English words, a given word, as you know, might be interpreted by different designers as a different meaning, right? So if you say something like the system should always be up. So if you just say always, like our say the Moodle should always be up, especially during a situation like this, but it is not always up. But still someone can argue it is always up. We calculate like this, out of say 24 hours it's up 23 hours, okay? But if you just say always, it just doesn't specify how much hours, number of hours or minutes, right? So just describing with words will allow others to misinterpret or have to understand differently. And it is non-rigorous. So being non-rigorous, not following syntax, will introduce ambiguity as well. Different people will understand it differently. And it is non-formal. So just specifying with natural language is not considered part of the documentation of the system. So if you are doing US government projects, this will not qualify as the documentation, right? So if you get litigated, if the client takes you to court for not complying with their requirements, the company, the software company, will not be able to show the natural language descriptions of the architecture as part of the legal documents. And it is often verbose. Verbose mean like a lot of words are used, right? A lot of like it might, like if you take the natural language model, it might span a few pages. So you will have to read all the pages to get to the design spec, right? So unnecessary words are there, verbose, too many words, too much words. So that is a disadvantage, because you might like waste time writing all those unnecessary details, and it cannot be effectively processed or analyzed by machines or software. Now, there are case tools, computer aided software engineering tools, that are now able to automatically create software code, right? So when you draw the diagram, it generates the code automatically. So that kind of tools only support the pseudocode type of things and the diagrams. So if you draw a UML diagram, say something like Rational Rows, the newer versions, if you draw the diagram, if it is simple enough, the Rational Rows can create a code snippet for that part, right? So that kind of advanced tool support is not there when you use normal English or natural language to model your architectural diagrams. So for example, if we use a description like given in the slide now to talk about the lunar lander. Now it might include a lot of details. Okay, a data store component, a calculation component, and a user interface component. And the job of the data store is described, the job of the calculation component is described, and the job of the user interface is described. So a lot of words. If you want to get the details, now imagine the designer or the implementer who has to now write the code will have to read all these words. Now, would you prefer to read all these to write the code, or would you prefer to look at a UML diagram, say the class diagram? Normally we are used to looking at a class diagram and implement, right? And then get the details, the required details by looking at the sequence diagrams, the activity diagrams, the use case diagrams, the component diagrams, the interaction diagrams, the communication diagrams, right? So all these, now we are kind of like all technical people, the designers, the programmers, everyone is kind of like are trained to look at the diagrams, whether they are UML or just simple flow charts. Even a simple flow chart will give you more details in a smaller time than what is on the slides. The advantages are here the non-functional requirements can be clearly stated, right? So you have to like appreciate the good while being aware of the disadvantages here. Then there are a few related alternatives to natural language. One is the ambiguity. Now we can reduce the ambiguity by following statement templates. So rather than allowing the architect to write anything, you just give a form. So it's like filling a form. You identify what are the name, then the list of the elements, then whether it is synchronous or asynchronous output, then the input and the products. So identify the components that should be there in the document, then it just becomes filling the form. So it kind of limits the creativity of the architect, but it is better because it reduces the ambiguity. And it introduces rigor. So it kind of gives a syntax, introduces a very low level syntax by specifying this statement template. So this can help to make rigorous data easier to read and interpret. But such information is generally better represented in a more compact format. So even though these statement templates allows you to read and interpret the rigorous information easily. So now the things will be highlighted. So the important information will now be highlighted. But still, there are better, compact, more summarized formats like the UML. So just draw the diagram, everything is much more clearer than in this kind of statement template form, right? But you have to really appreciate how natural language help us include more high-level design decisions. So the scope and the purpose of natural language is to capture the design decisions in the prose form. Prose is the text, okay, in a prose form, like a description, in a descriptive form. It will have more details than the diagrams, right? So if comparing with the UML diagram, here you can include all the details, right? So the scope and purpose is to capture the decisions in the prose form. And the basic elements are any concept. Okay, any concept you need, you can now include. Okay, no limitation. And the style that you want to follow can be described by using more general language. So the architectural style you want to follow, you can just use normal English. So general language. Okay, you don't need technical knowledge to follow, understand it. Then the static and dynamic aspects are that any aspect can be modeled, and the dynamic models, it is not restricted. Okay, but the dynamic models, you cannot really show real time here. It's not like a simulation software. You will not have a model that is changing with time. And there is no direct tie to implemented models and the running system. So because it is just text and it's not gonna change. Okay, no animations or anything here. Then the non-functional aspects, you can use any word, any adjective, any adverb. You can use all the nice words to describe your non-functional aspect. So expressive vocabulary is available, but the problem is there is no way to verify here. You just state whatever you like, but you cannot check back with the SRS documents, or there's no automated validation here, right? Then the ambiguity is very high because plain natural text is used, and different people will understand it differently. So it depends on your knowledge about English language and the way you use, especially if you are working with in a distributed system with different nationalities, right? If a Chinese person is there, his vocabulary will be very limited. He might not understand what you are saying, right? So that kind of problems will be there. You have to be aware. Then the accuracy. You can check for the correctness manually, because it will take another human to really understand this natural language and to inspect. You cannot rely on the case tools. And the precision, whether you are doing it at the right level of description, you can add text to describe any level of detail. So it is unlimited precision. Okay, if you need the details, you can add the details here. Then the viewpoints, any viewpoint can be supported. Okay, any viewpoint that you have in the architecture style you are following can be supported, but there's no support for any particular viewpoint, no advantage for anything. Then the consistency among the viewpoints can be manual reviews and the inspections. Okay, so everything you have to do manually. Another human will have to do everything, and you have to inspect again manually. Then we have the informal graphical modeling. So things like the flowcharts that you learned in the earlier programming languages before you learned UML, remember? Flowcharts and various diagrams you learned at school to model how to program, right? So these are known as informal graphical modeling because there are no universal rules. So sometimes in companies also, you like just jot down your ideas and share around using various graphical models. So these general diagrams produced in tools like PowerPoint and OmniGraffle. So there are general software that are able to draw diagrams quickly and no strict rules. So the advantages are they can be aesthetically pleasing. So when you want to go and talk with the business side stakeholders, business owners, the users, they will find it very easy to understand. Right? Rather than a use case diagram, they might prefer these kind of diagrams where there are no syntax, right? And then the size limitations generally constrain the complexity, because if you take a PowerPoint, there is an amount of diagrams or pictures you can include in one slide without losing the comprehensibility. So if you just include two small figures, so many smaller figures, it will become complex and the people will not be able to understand. So that is the only limit. And it is extremely flexible due to large symbolic vocabulary. So there are a lot of images. So if you just take PowerPoint, just in PowerPoint, just go to the tools and look at the pictures. There are many hundreds of pictures, and you can even download pictures from Microsoft if you want. So the symbolic vocabulary is so big. So any idea you can just make a diagram. But the disadvantages are it is still ambiguous. Different designers, especially people with different backgrounds, like the business domain people will identify symbols as some different thing. Now the technical people might refer to things with there will be some consistency among the software engineers, but in other disciplines, the symbols might denote specific meaning. So there is room for ambiguity. And it is non-rigorous as well, because there's no strict syntax. There's no strict rule about what means what. And it is still non-formal. It is not part of a formal set of documentation, but it is often treated otherwise. So if you draw, say, even something like a DFDs or a data flow diagram or a flow chart, right? The flow chart might get into the formal documentation, but it is actually not a good formal representation. But anyway, we cannot effectively process or analyze these models. Say if you just draw a flow chart, there are no case tools that will take the flow chart and generate the code. So, and there is no validation software to support the flow charts or the diagrams you draw with the PowerPoint. So there's another disadvantage. So the informal graphical models, for example, you can draw a diagram like this. Take the PowerPoint tools and take some 4 cubes, like 3 cubes and the arrows, and just show your diagram. So this is a representation. So it gives you the basic idea about your architecture. There's a UI component, a calculation component, and a data store component. So this is not UML, right? But it has the required information, and it is more concise than natural language. So rather than reading a 2-page document, just looking at this, you will get the basic idea. So there are few related alternatives. There are diagram editors like the Visio. Visio supports UML as well as it has its own set of diagrams. So it can be extended with semantics through scripts and other additional programming. So you can run the scripts and it will create the .NET. You can configure it to generate C# code. They generally ends up somewhere in between a custom notation specific editor and a generic diagram editor. So if you take something like a Visio, even Rational Rose up to a certain level, is mix between a custom notation specific editor, right, and a generic diagram editor, because it supports a certain up to a level universal syntax is supported, and it is limited by extensibility of the tool. So if you use Visio, sometimes the extensibility is only to the .NET platforms, right? So like that, you have to be aware of the limitations of the tools. Then if you use something like PowerPoint editor, right? So using the diagrams available in the PowerPoint, you can create your own set of vocabulary. So if you are limiting yourself only to the diagrams available in the PowerPoint, up to a level, you can integrate the semantics into the PowerPoint. Then when you want to evaluate the informal graphical models, if you evaluate about the scope and purpose, now you can draw any diagram you like, right, using these kind of informal modeling tools like say PowerPoint or the Visio's own tools. Now this is not the UML, right? Without the UML diagrams, if you draw, it leads to arbitrary diagrams. Okay, there are different diagrams. Diagrams will look different, consisting of symbols and text. So scope and purpose will be okay, can be described nicely. Then the basic elements, okay, basic elements will be different geometric shapes. So there is no set of limited set. Any shape will be there. So geometric shapes, splines are lines, and then click parts, text segments, anything can be there. Then the style, in general, it doesn't support any given architectural style. Anything, everything is generally supported. Then when it comes to the static and dynamic aspects, you cannot really include animation. Now in PowerPoint, you can do a little small animations, but all these aspects can be modeled, but no semantics behind the models, right? So the static and dynamic aspects are, if you want, you can model, but there are no meanings behind the animations that you include. And the dynamic models are rare. If you play around with PowerPoint, you can sometimes include a little bit of simulation kind of animations. So it's rarely supported in these tools, although APIs can be used to manipulate the graphics, right? So you can do, but sometimes it takes more time to do this dynamic modeling than the benefits that they give. Then the non-functional aspects are, you can like, since these are graphics, you will not be able to express the non-functional requirements very nicely. So again, you will have to annotate with natural language, just like in the natural language. We have to give the adjectives, the adverbs that describe the non-functional requirement. Then the ambiguity can be reduced through use of the rigorous symbolic vocabulary or the dictionaries, right? So if you reduce the amount of words that you use, that is, you follow your own syntax, you create a set of rules and follow it. So within a company, you can reduce the ambiguity. And then the accuracy, still only manual reviews. Some other person, some test engineer, some will have to read manually and understand the text, because the important things are still in the textual format, and there is no rigorous syntax. There's no rule, right? Then the precision is up to the modeler. The level of details, it's up to the modeler to decide. So if you want very highly descriptive, say you can take one PowerPoint slide and have a very big model in one slide, right? If you want more details, but there's a limit to the details, because it is limited to this, because this graphic, you cannot have a multi-page graphic. So if you go try to draw multi-page graphics with arrows going from this page to that one, that page, from page 1 to 2, 1 to 3, 1 to 4. So it's going to be too complicated. So usually the precision is decided by the amount of space you have on the given tool, say PowerPoint, size of the slide. And then the viewpoints point of view, any viewpoint can be supported, but there is no advantage for any given viewpoint. Right, then the viewpoint consistency, you will have to manually review and inspect, so there is no advantage there as well. Then let's compare the UML, right? The UML that you have already learned. Now we are referring to the UML first standard here. So there are 13 notations called diagrams that capture the static and dynamic aspects of software intensive systems. And the advantages are they support diverse array of viewpoints focused on many common software engineering concerns. Right, so you know there are dynamic diagrams, there are static diagrams, diagrams that show the user's point of view, diagrams that show the behavior, right? How the structure, right? How things change with the time, right? So many viewpoints are supported. And there's ubiquity, improves comprehensibility. Ubiquity means the same thing can be modeled with different diagrams. So you can draw the class diagram and a use case diagram, and you take a use case and have more descriptions. You can draw the collaboration diagrams and the activity diagram for the same thing. So for the same component, you can have multiple views, right? So it improves comprehensibility. So by looking at one diagram, if there is some ambiguity, it will be removed by looking at the other diagram. And there is extensive documentation and tool support from many vendors. So as you may have done in your UML practicals, okay, you might have used, say, I don't know, what did you use? Rational Rows or Visio, or there are like various other open source software available to draw UML, right? So all of them have documentation. Okay, they describe how to draw the diagrams you need. So there is one syntax is there. Then there's tool support. So say Microsoft Visio, if you draw the UML, right, you can be certain that it will generate the correct C# code if you have enough details. So a lot of tool support is there. But the disadvantages are that UML needs customization through profiles to reduce ambiguity. Now, even in UML, there can be ambiguity. If you do not customize the UML diagrams by introducing the profiles, right? You have to profile to the specific project. Then only you will be able to reduce the ambiguity 100%. Right? But still it's better than the other methods. Then it is difficult to assess the consistency among the views. Now different diagrams will give you different views, right? So the consistency, assessing consistency is not always supported by the case tools, right? It will have to be manually done. Then it is difficult to capture foreign concepts or views. So foreign concepts that are outside the domain. Now, when we start UML modeling, we set a boundary, right? So whatever that we mark as out of the boundary of our system, okay, might not be included in the models that you are like trying you do with UML. So it becomes difficult to capture the foreign concepts or the foreign views. So because UML only supports the object-oriented approach. So if there is some foreign view that is not included in the UML paradigm, so UML, the object-oriented way of thinking. Now, if you are able to describe your problem with all the object-oriented concepts, then yes, UML is a very good choice. But there might be problem situations, real-world problems, where the object-oriented approach is not enough, right? In that kind of situations, UML will not be enough to express your concepts, right? So that is one disadvantage you have to be aware of. So here we have a few UML diagrams. So I will not go through the details here. You can you know what these are, right? So all these UML diagrams. We are not going to learn UML here in this course. We are focusing on the architectural models, right? So it's okay if you have like forgotten the UML as well, but we will do a little bit of practicals later on. Okay, so here a few UML diagrams are there, and the purpose here is for you to understand that there is this particular syntax. So if two designers draw the UML diagrams about one thing, they should look more or less the same, right? So accuracy is high. So when you evaluate, you understand that scope and purpose is limited to diverse array of design decisions in 13 viewpoints only. So only those 13 are covered. If you have something else, some other concept, it is not covered in UML. Then the basic elements that are covered by UML, it has concept of state, classes, objects, composite nodes. So all those object-oriented elements are there in UML. Then the style of modeling is through the object component constraints. So through the so you know, like when you do object oriented analysis and design, you go through the descriptions and identify the possible objects and the classes and how they are connected, right? So that those constraints are there in the UML. Then the static and dynamic aspects are that some static diagrams are there, like the class diagrams, package diagrams, and some dynamic diagrams. These dynamic means like it's not real data. These diagrams don't change with time, but they show how the model changes with time, because a timeline is there in the activity diagram and in the state charts. So sometimes the timeline is there, sometimes it just shows how the possible states that a system can take. So then it is dynamic, but it's not really dynamic model, right? So dynamic models, when it comes to dynamic models, it's rare. So there are a few case tools that can show the runtime changes. Like there are, say if you do .NET and it's supported by Visio, and like if you configure it to show this how the C# code runs, then it might show these components. It might highlight and show a little bit of animation to show that this is running, this module is running. But it is rare, and it depends on the environment, right? Then non-functional aspects, still there is no direct support, right? There are no diagrams for non-functional requirements. So natural language annotations have to be added. So you have to still have the descriptions. So all these annotations are just textual annotations. You have to describe using natural language. It's still just English. Then the ambiguity, right? Because many symbols are interpreted differently depending on the context, profiles reduce ambiguity. So because the same set of symbols are used in the diagrams, unless you do profiling, so you in the profile you define this diagram, this symbol means this. So with the profiling, you can customize the UML to a certain extent, and then within that context, it is clearly defined. Then it reduces the ambiguity. Then the accuracy is high because the well-formedness checks, then automatic constraint checking, and there are a lot of case tool support. can ensure accuracy, and other accuracy checks will have to be done manually. Then precision, the amount of detail that you include is up to the modeler. You can include any amount of annotations, right? If you want details, you can add all the details as annotated text. So there is wide amount of flexibility. If you don't want any text, you can just have the graphical part also. So it's up to the modeler. Then the viewpoints that are supported specifically are that there are only 13 viewpoints, right? So each diagram type represents a viewpoint, and more can be added through overloading or profiling. So you can overload. So this is supporting. UML itself is based on the object-oriented concept. So you can have a hierarchy of, you can define your own overloaded set of diagrams through the profiling tools and support additional viewpoints. Then the viewpoint consistency, you will have to manually check if you want to capture any errors. But the constraint checking can be done automatically using the case tools such as the SATs tools available. Okay, so that kind of advantages are there in UML. Okay, so I think that's the end of the lesson today. So thank you for those who participated. I know you joined in the middle. Anyway, I will upload the complete lecture recording to the LMS when it is available. So thank you.